Everyone, so today I'm making a video to show you how to properly understand the property tables. So how to read them and how to go from these graphs here. So we have a TV, so temperature and specific volume diagram, and a pressure and specific volume diagram. So we have two of them here. They're very important, and I'll teach you how to read them and go from there to the property table. So I'll take the temperature and specific volume property table as an example. So pretty much there is three big main regions here that we have to look at. So we have the compressed liquid region, we have the saturated liquid vapor region, and we have the superheated vapor region. So pretty much what happens is initially you're starting at a certain temperature and a certain specific volume, okay? What happens is you are heating up that, so by the way, this has to be for pure substances, okay? So you're heating up that pure substance. For example, water. Water is a pure substance. So what we're doing is we're heating it up, and as we're heating it up, the temperature, as you can see, is increasing, and the specific volume is increasing. But at this point here, we're still in the compressed liquid region. Compressed liquid pretty much means it's still fully liquid. There's nothing happening there. But we approach this specific line here, and then what happens is we're at the saturated liquid line. Pretty much what that means is we are still in the liquid phase, but any additional heat or any additional, pretty much any additional specific volume increase will result in vapor forming, which gets us in this very specific region, which is called the saturated liquid vapor region. So I like to see them as borders. So there's a border here, okay? So as you're crossing from the compressed liquid region, you're going into the saturated liquid vapor region. So we're having now liquid and vapor at the same time. As we increase from this area here, we're going towards the saturated vapor line. So this is what we call the quality, okay? So because you don't know exactly where you are in between here in the saturated liquid vapor region, are you very, very liquidy, or are you very, very vapor here? So it transitions between liquid to vapor throughout this area here as we're increasing the specific volume. Remember, the temperature is staying the same. And then we get to this area here, and pretty much what happens when you get to the saturated vapor line, that means it's pretty much all vapor at this point. So any additional heat added to the system will result into what we call superheated vapor region. That means it's been superheated. So pretty much, again, I'll just recap everything. We're going from liquid to liquid and vapor to superheated vapor. All right, very important thing to keep in note here is that the pressure is constant. So the temperature and specific volume will have constant pressure. While if we look at the pressure and specific volume, we have a constant temperature. Although it looks like it's changing, what's changing is the temperature and specific volume throughout the whole process, not the pressures. The pressures will remain the same. What we just learned about these graphs and the property tables to solve a quick example, okay? So the question says, so we have a temperature of 200 degrees C and the pressure of 2 megapascals. So it says, which region are we in? So the first thing I like to do is always, so since we're looking at a T and V diagram, I like to plot the T on the axis. So we have 200 degrees here. So let's make a line. This is the line of 200 degrees. Alright, just like that. So that's your temperature at 200 degrees. Now, at this temperature, there is a saturation pressure here, which is right there. Now, to know this pressure, remember, this is the pressure given to you in the question. This is not the saturation pressure at 200 degrees C. Now, to find what it is, we have to go to the property table. So if you go to the property table, and we're here right now, remember, there's three types of tables. So now we want to go to the saturated water table because we're dealing with water, and we want to know what the saturation pressure is. So we are at 200 degrees C right here, as you can see, and it's telling us that the saturation pressure in megapascals is 1.5538. So that means that if we go back and we make a quick line like this, just like the lines that is given to us, and you have it going through like that and back up. All right, so this area here, this is the P saturation. All right, so this represents, like we said, it's 1.5538. Just to make it easier, I'll just say 1.55. All right, now how does this help us? All right, so now we have the pressure here, the Psat. The problem is giving us at a pressure of 2 megapascals. We have a pressure of 1.55 megapascals. So logically, since this is a constant, the line, which represents 2 megapascals, will be a bit higher, right, than 1.55. So if we go a bit higher, like this, and we make another line, so this one is P equal to 2 megapascals. And as you can see, the 200 temperature intersects with the 2 megapascals at the compressed liquid region. So this is how you pretty much do it to know which region you're in. For example, if the problem gave us, let's say 1 megapascals, I'll just make my own problem right now. So 1 would be here. So we would have a line like this going up like that. This would be P equal to 1. And that means that we are in the, as you can see, the superheated vapor region. So it's this simple to know which region. The question is asking us, what is the specific volume 65% through the saturated liquid vapor region at 300 degrees C. So again, if we make a line like this, this is the 300 degrees C. All right, and then again we have saturated Psat here, which is equal to something. We can find it from the tables. Now, how do you know what is the, first of all, how do you know the specific volumes at this point and this point here? Okay, so this is very simple to do. We go to the we have to go to the tables here at 300 degrees C for this saturated water. So if we get saturated water, 300 degrees C would be here. All right, and as you can see on the top, saturated liquid. So the specific volume is given to you here. So you go down at 300. So at the specific volume for the fluid is 0.001404, and the at the gas part is 0.02167. So these are the two values you have here. So you have one value here and one value here. So that's how you would see it. You can go down like this and you can see it very easy. Now the question is asking us 65% through. So this is where the confusing part is. How do I know what is, let's say 65 would be here. Let's say what would be the specific volume here? How would I know that? The table is not showing it to me. Well, there's a very simple equation that you can use that can easily show you exactly where you would be, and this is the equation here. Now you might be wondering, why am I using y? Well, y can be anything in this table pretty much. So as you can see, you have specific volume, you have internal energy, enthalpy, entropy, you have a lot of things here which can be used as your y. Y is just a general term. Now we are using specific volume, so this would not be a y, it would be the specific volume. Alright, so what does this equation mean? Y is what you're looking for. So y is the specific volume the question is asking you. And then you have y of the fluid, which is the specific volume of the fluid that we can get. So this one here, so this would be yf. Alright, and then you have so this is the important thing. This is the what we call the quality. So this is the 65%, and this would be 0.65. Alright, so it's here, and then you times it by the specific volume at the gas, so y of g, which is here, minus your y of f again. So to understand this equation, it's very simple, right? If your quality is at 0, so it's asking you what is the specific volume is 0% through. So you're at 0% through right here. So 0 times this, the whole thing goes to 0. So pretty much your y is y of the fluid, which makes sense, it's here. Now what if it's at 1? If this is 1, this whole thing is maximized, so you're pretty much doing yf plus 1 times this whole thing, which will bring you right over here. Alright, so it's this simple. you pretty much have to plug in the equations. Everything is given to you, and then you simply just find the y.